Welcome back, students. So here we are on the 7th course of our journey. Okay, so again, as I said, the miscellaneous part was divided into the third part and we are in the second part. We left at differentiation and we will begin with integration in this part, and we will also do binomial theorem for any index. Till now we have discussed binomial just for whole numbers. Okay, now in this part for any integer. Okay, so you will be again saying, oh my god, if the natural number was so horrible, how will it turn when it will come to a negative integer or a fraction or any rational number? But the story is quite easy, as you will see. Let's begin with the part. Talking about the use of integration, now as we did in the previous part, when something was being multiplied with the coefficients, we were saying that let's make the power of k and then differentiate to make the coefficient with the constant k. Now integration is exactly opposite. Instead of this k appearing here, it will appear here. Okay, now again I will write the basic which we are doing since the first thing, and now you will be very comfortable with this one, I hope. And if still you are not comfortable with this, then again go back and see this. Okay, yeah, so this is the general thing. Now I say that initially what I was asking 2 and c1, then what we said, okay, multiply it by x to make it x square here and then differentiate. Okay, but now instead of this I say, if the question comes like this, okay, NC2, find the value of this thing. Okay, now here immediately it should come to your mind that we are going to integrate this thing. Okay, now again here if you integrate this thing, okay, so this is again very easy, that what you will do, increase the power and n plus 1, and this will be nc0x plus nc1 x square by 2 plus nc2 x cube by 3. This will go like this, and once you substitute x as 1, you are getting this form, whatever is required. Okay, but again never forget, if nc0 is not asked, which is in many cases not asked, it may be starting with nc2, then you have to adjust the first two terms on the left hand side, because whatever is required, that will be your right hand side. Okay, and left hand side, once you put 1, it will be 2 raised to power n plus 1 divided by n plus 1, and it will go on. Okay, and this will be 1 here plus this was your required expression. Okay, now based on that, suppose it's 4 required here, so what you will do, first multiply by x. Okay, and then in this case you have to just apply a bit of substitution for integration. Again note that integration is bit difficult at times as compared to the differentiation. Differentiation is quite easy, but integration, again you will just have maybe x square x cubed like that. So in that you will have to substitute 1 plus x as t, and then you will accordingly substitute the various things. Okay, so integration will be based similar to the differentiation. Now if we are getting summation of this form, NCR, sorry, so what we will be doing, we will be using the differentiation. If we are doing the submission of this form, we will be using integration, and this value will come from the power of x, and you will be substituting finally x as 1 to get the coefficient. Okay, so moving on to the next important concept, which is the binomial theorem for any index. Okay, again a very important result. Up till now I said in the beginning there will be two cases, one for natural numbers, the index was natural number 1 2 3 4 0, obviously it's 1. Okay, so we can either say it as whole number, and this one will be non-natural or whole numbers. Okay, although this is applicable for this also, you can just see that this is nothing but your NC2, this is nothing but NCR, it will form basically, it will go on like that. It's NC1, NC0 and x Okay, so it's same only, so no difference regarding that. But again, here the important thing is not to notice that uh, the power can be anything. So suppose if I am having x raised to power minus half, so this I can write it as 1 plus, now this is n here, this should be noted, nx plus minus half into minus half minus 1 by 2 factorial x square. It depends up to what accuracy we are actually requiring the things. Okay, so this is very useful results for even for finding decimal. Suppose if you are given maybe 9.88 or something like that, raised to power something, say half minus half, this thing one. So what I'll do, I'll immediately write it as this thing I'll convert in this form. Okay, again, instead of this, suppose 1.8 it was there. Okay, we'll start with an easier example. Then in this case, what we would have done, we would have make it as 1 plus 0.88 raised to power minus half, and then we will have substituted, suppose up to 2 or 3 decimal places. So this would have been 1 plus minus half into 0.88 plus, it's the same thing, instead of x square it would have been 0.8 square. Okay, so if we need up to 2 places, maybe this was not required because this will become very small. So up to only this term we can have an approximation. Okay, so this is very useful for approximation. Again, basic application of this one. And again, for any general expansion you can use the binomial theorem of this index. Okay, so very useful formula. Just how you need to do 1 starting with 1 nx, then n into n minus 1, since there are 2 terms, 2 factorial by x square, plus next will be n minus 1 is there, so n minus 2 will be there by 3 factorial. So this is the way you can remember the number of terms, power and the factorial, those are related. Okay, so not a worry. And again, moving on to the question now, which we discussed about the properties. Okay, C0, these are the binomial coefficients, then limit x tends to this. Okay, so these are the options given. Okay, so this is a multiple choice question picked from JEE mains. Okay, so again, this question, the trick here is that C0 and Cn, basically if you see, it's a very simple question. The just important thing is we have to correlate with the power and the number appearing here. So if I convert it as C0, because C0 will be Cn, basically it's written in the opposite order, minus 2 by 3 C1 plus C2. Now this series starts making some sense. How? I can correlate the coefficient with the power. Okay, so this is nothing but alternate, since it's alternate plus minus, so obviously 1 minus 2 by 3 raised to power n. This is the expansion of this. Again, you can check that this is, now I am able to relate this coefficient with the power of this. Okay, the subscript under this. So this is 2 by 3 1 by 3 it will become, and anything less than 1 raised to pi infinity will become 0. Okay, so A will be the correct answer for this. Again, this was basic thing, that in this we just use this thing, NCR is equal to NC n minus r. This is the property which we have applied here, and we will be doing more questions in the coming parts which came in the JEE, in which we will be applying the concepts of integration, differentiation, which we have already discussed, and whatever properties which we did, and the properties which are again remaining we will be covering in the coming parts. So I hope till this the integration and differentiation, it should be very clear, and by now you should be very comfortable with multiplying the things, getting the visualizing this a term as a coefficient or as a term of binomial expansion. So I hope that if in the previous part differentiation was clear, integration would have been more clear in this part. Plus the binomial theorem for any index seems to be most easiest part of the topic. But in the next part we are going to discuss about multinomial theorem. Okay, here we played with powers. Okay, but in the next part we are going to play with the number of terms. That's not easy, my dear friends. Stay tuned for the next part.